As we discussed, functions are the building blocks of programs, and we've been working with functions from the beginning of this course. The functions we've been using, such as line, rect, and ellipse, are functions built into processing. These are referred to as built-in functions because they are provided as part of the processing language and are not defined by us. In this video, you'll learn how you can make your own functions and how you can use them just as you would use built-in functions. The first thing you need to know is how to define a function, which is how you'll let processing know that it's this particular set of instructions that you'll want to use again and again. The definition of a function is called the function signature. And just like your own written signature, a function signature is unique and is the way the computer recognizes your function. To have a valid signature, we need to specify the return type, the function name, and any arguments that the function has. Remember rect and how it had 4 numbers after it? Those 4 numbers were the arguments to the rect function, telling processing where to start drawing in xy coordinates and how far to draw in each direction. The return type of our function is the data type of the information that our function returns after executing. What do we mean by our function returning data? If we had a simple function which added 2 numbers, then we would want to be able to use the result of the addition after the code inside the function has reached its end. If we didn't return this value from the function, then we wouldn't be able to use it. So in the case of addition, we want to return an integer, which is the result of the numerical addition operation. What if our function doesn't return anything? Perhaps it just draws a line onto the canvas. In processing, we use the special word void to indicate the absence of a returned value. Any function that has the return type void does something, but doesn't pass any values back once it's done. The function name is the name we would use to execute our function, which is referred to as calling the function. If we wanted to draw a line on the canvas, we would call the inbuilt line function, which executes the line function and draws a line. Function names have some style guidelines, common practices that make your code easier to read. Usually functions only start with lowercase letters, and just like good variable names, function names should be useful, describing what the function does. The last piece of the definition is to specify the type and number of arguments that our function takes. For example, the line function accepts 4 floating point numbers, which represent the starting point and the end point. If our function did not have any parameters, then we'd simply have no input arguments for our function. There are times when we do this, but we'll cover examples like this later in the course. After we define the signature of our function, we write the code that will be executed when we call the function. And the code to be executed is written within curly brackets. Although we can define variables inside a function, processing throws away variables defined inside functions once we leave the function. We'll come back to this later in more detail where we'll talk about the scope of variables, but for now it's important to remember to return any results you want. If a value isn't returned, processing forgets about it once the function has finished executing. In the next video, we're going to investigate how we can use different functions in our programs.